Hello students, let's have a look at the 2024 paper 2 for Edexcel GCSE Computer Science. Now, as always, I highly recommend that when you open up the student coding folder that you immediately save a version as per the question, for example Q1 finished. So that you've got the original Python file, which you're not meant to mess around with anyway, and plus you can look back at the file. So I've put all of these up here, so even though they say Q finished, we have to go through the question, but just get into the habit of save as, and then uppercase, no spaces. Let's have a look. So a program is written to provide the information about the rainbow. Okay. Colours and wavelengths are stored in arrays. For example, colour violet is produced when the wavelength is 380 to 424. The user enters an index and the colour at that array. The user enters a wavelength. So there are 10 marks here, and there happen to be 10 bullet points. So we just need to fix each one. Fix the syntax here on line 5. Well, we've got this kind of, and you can see Thonny's actually trying to tell us that there's an issue. Just get rid of that little rogue quotation mark, and we're done. Fix, and as you're going through these, like literally go highlight them as you're doing, you tick them off. Fix the name error on the original line 6. Okay, well, Boolean values should have uppercase letters. And you can see that the syntax highlighting has changed accordingly. Fix the error on line 8, syntax error. So what is well, these are global variables, so we wouldn't expect to have anything in there, just an integer. And then we enter the wavelength later on. So it's not necessarily a syntax error in that sense. I mean, I guess 0, 1, 2, 3 is not a valid integer really, is it? But anyway, that's what they want you to do. Fix the syntax error on line 15. Okay, where's the closing bracket? And you see already the colour's changed because we fixed that error. Because we've got the input statement and the closing bracket for that's here, we're changing it into an integer. Fix the name error on line 21. Fix the name. How can we have an integer? Yeah, hang on. Right, there are two issues here. Well, first of all, let's just deal with this one. That's easier. Print color. Oops, sorry. Fix the name error. Looks okay to me. We'll come back to that because I can't see any issue with that particular line at the moment, unless my file had sneakingly had it sorted out. Index is right. Index is here. Color, American spelling, rainbow. Yeah. Okay. Right. Let's move. Let's carry on. Oh, American spelling. So that's what's confusing me. So technically speaking, Python does use American, US English for things like when you're doing Python as a title and you're using color, it will expect you to use the American spelling. So that was the issue there. Good. Okay, so we can just have to take a look at that one a little closely. Fix the logic area on line 26. Okay, so if the wavelength is less than 380, and can it be and? I think that would be or. It'd be better if it's one or the other. It's either less than that number or it's greater than. Can't be both, can it? Otherwise that would be an issue, that we can't actually have that statement being true. Print invalid in wavelength, fine. Fix the logic error on line 29. So we're incrementing the index, but we really should be looking at index 0 to begin with, because if we're traversing a data structure, violet and 380 are index 0, and then we're updating it here. We've got a global variable 0, so that would be this. Fix the logic error on line 35. So else if the wavetable index, right, is probably to do with this here. So logic errors will usually run, it just means the program won't work properly. So if the wavelength does equal the wavetable, fine, found true. Else if the wavetable, it wouldn't be less than or equal to, I think what it should be would be greater than the wavelength. So if the one we're looking at wavetable at that particular index is greater than the wavelength that they've typed in. And then lastly, fix the logic error on line 37. So my eyes are going to this index -2. So I would expect that to be an index -1 at this point. Yeah, I think index, you wouldn't have a -2 there. Rainbow, and then whatever our index value is, and take away 1 from it. And you can test this out, obviously. Enter an index, let's say 3, green. Good, okay, I think that's enough for question 1, that should be okay. 0, 1, 2, 3. Yeah, if it wasn't producing the right one, then you could go back to it and check. Question 2, let's move on. A program encrypts a message using a Caesar cipher, so a very simple encryption algorithm that uses a key shift, essentially. So we've got all the code here, we just need to sort of switch on the right ones, really. Now there'll be a shift here in the alphabet, so obviously T, well, let's go with A, and then if we went backwards on the alphabet, 5, you get the V. So that's, let's do an easier one, A, B, C, D, E. So shift by 4, you get E, just to show you that the shift means we shift in the alphabet. Right, so amend the code to make the program work. Choose between alternative lines of code. Make a choice by removing the hashtag. Okay, so we've got all these comments, and we simply uncomment one that we expect. So let's go through. Choose the correct line to check for alphabetic characters. Well, alpha is the way that we can check if a letter is an alphabetic character or not. That is in the PLS subset document, so you don't have to remember all of these methods. They are there. Now with ASCII you've got ORD and char. So if you've got an ORD, you can get returns the number, the order in which it is in the ASCII, and you can do the opposite. If you've got a number, you can get the character by using CHR. Choose the correct line to check for uppercase. So is upper is the best method there. This one converts it to uppercase. Pardon me, sorry. Is alpha, we just use that. Is lower, is upper. Good, so it's 2 marks straight away. Choose the correct line to check if the letter is outside the alphabet. If it's outside, so if it's greater than Z, essentially, if it's greater than Z, then it's outside of our scope, isn't it? Not greater than or equal, greater than. 60's A, by the way, on ASCII. Choose the correct line to check if the letter is outside the alphabet. So this one is kind of like the opposite. It's like if it's less than A. If it's less than the string A, because we're checking the order if the value is less than that and 60. Okay, choose the correct line to check for lowercase. So it's very similar to what we just saw. Is lower is the best one there. Choose the correct line to check if a lot of these you could guess. Check if the letter is outside the alphabet. Now we're doing the same, but for lowercase. So it's just greater than, and then for this one, less than. So if you got the other two right, you'll be able to get these right as well. Choose the correct line to set up the variable new letter. Right, okay. So if we've got a value, we can create a character from it by using CHR. So that would be the most appropriate one. ORD returns a number, the order, and that's using the wrong variable. Choose the correct line to create the encrypted string. Ciphertext equals new letter plus ciphertext. So if you really were struggling with this, you could just do a bit of trial and error, because ultimately we know this will work. With putting the rainbow in, it should give us the ciphertext. But I think the best one here would be to take whatever's in ciphertext and then add our new letter to it. To concatenate using the plus. So that order is normally what we see, like for example, value equals value plus something, or total equals total plus something. And then else, choose the correct line to create the encrypted string. So ciphertext equals ciphertext plus our letter that we have. Let's run this. Enter a message. I'm going to put the rainbow. Enter the shift 4, and it should give me XLI. Yeah. So if you got to the point where you were getting confused with these two in particular, just try different permutations, particularly this last one. Try different permutations if you get it right. But the important thing is to check with a bit like trace tables, actually check through the data you've been given so that the intended output is there. Right, so let's have a look at question 3. We've got some constants here written in uppercase, global variables, which were these variables have been initialized with these default values. A program is required to calculate the total cost of items produced. Items are sold by count or by weight. Again, we've got like a little trace table thing that we can plug in numbers and get an intended result. We want to use that to make sure that all of our inputs produce the correct output, and then we know our code is working. Amend the code, and we've got 10 marks, and we've got 1, 2, 3, 4, 5, 6, 7, 8, essentially those 8 bullet points. Just go through methodically. Create an integer variable name, so that's pretty easy. Okay, creating an integer variable, it literally says here, create an integer variable. So copy and paste it. Don't overthink this. Equals 0. Nice and simple, right? Nice and simple. That's 1 mark. Literally just tick it off. Complete a line with the correct logical operator. Okay, so it's down here. What's the correct logical operator? So, if purchase type does not equal, okay, purchase type weight, and what's the other one? Purchase type item. I think if they don't equal those, that makes the most sense. And let's see what would be a good and the correct constant. So I think the constant's right, and then do we use and or? I think and here. We want to check for both of them. Sorry, just write lowercase. If purchase type, so this is does not equal. So if the purchase type, this 0, does not equal purchase type item, this makes sense because we've got an integer input here. Enter a purchase type 1 or 5, and purchase type does not equal purchase type weight. Invalid purchase type. Yeah, I'm happy with that. I think that's fine. Next, complete the line with the correct constant. Purchase type weight equals, so else if it equals, I guess, purchase type weight, I'm just going to double click on my mouse. So rather than saving time and potentially making mistakes. So if it does equal purchase type weight, over here it's if it does equal, complete the line to accept a real value for the weights in kilograms. So we just need to make sure that we are putting the correct weight in, and they're points, so it's real numbers, floats. So I'm going to put a float in here and make sure that the closing brackets in there. Float, enter a weight in kilograms. Good, I think that's fine. If the weight is less than or equal to 0, got invalidation here, invalid input, that's done for us. Right, let me just go through my I'll check this. Complete a line to calculate the total cost. So here we go. Total cost equals weight. So let's have a look. Times total cost is just the weight times the price per kilogram, isn't it? Okay, so times, use asterisks, and then else count equals count number of items. If the count is, so similar to this, less than or equal to 0, it's an invalid amount of items, because you've got to make sure that it's greater than 0. And complete a line with the correct relational operator. So if the total cost is greater than 0, it's a float, then I guess we can print out a message and a display informative of the total cost. Make sure that you use a character return here to see where you would indent to, and don't use spaces on the spacebar. So print total cost is, and then comma, total cost. There we go. And then let's run, enter a purchase type, 1, count 3, and we've got the same total cost is 3.69. Let's run it again with the other data. Let's do 3, invalid purchase type, yeah. Let's do 5, enter weight, 4.5. Okay, so it gives us what we expect. So just check through the data that's in here so you can get the intended output. That's the best thing you can do for here. So we've got these constants that we're given: purchase type item, purchase type weight, price per kilogram, price per item. And then we've got our global variables initialized with the data types. We enter an integer between 1 and 5 if the purchase type does not equal purchase type item and does not equal the purchase type weight. It's an invalid purchase type. And we saw that with R3. Else if purchase type does equal purchase type weight. If it does equal, then we're getting a weight in kilograms. If the weight's less than or equal to 0, we say it's invalid. Same with count. Else total cost is the weight times the price per kilogram, or the total cost here is the count per price per item. And then if the total cost is greater than 0, then we print it out. Okay, a bit of a mouthful for a sort of question 3. Let's keep going. Right, here we go. A small cafe provides cheese, rolls, and crisps for community events. The table shows the amount of ingredients. An algorithm is used to determine how many crisps, how many rolls, how much cheese to order for the event. Crisps are ordered whole bags, partial bags. So I think we've got to be careful with our data types here. Rolls are ordered per pack. Pack contains 24 rolls. Right, so what's it asking for? The flowchart shows the algorithm for calculating the amount of ingredients that must be ordered. The flowchart, oh, right, here we go. So we've got to remember that parallelograms are inputs and outputs. Quadrilaterals are processes. That could be also defining variables. Rhombuses are decisions. And we've got the terminators here, start and stop, and they're all going to be labelled with arrowheads and yes or no for the rhombuses. Okay, so it looks as though we have to implement this flowchart, convert the flowchart to an algorithm, use the library and constants provided, fine, and use comments. So don't want to lose marks by not having comments, white space, or layout. So this is a 15 marker. So let's really think carefully about what our global variables might be for this. Okay, so I think we've got to be really careful with these global variables. For example, grams of cheese, order of the rolls order. So what we really need to do is just, let's be methodical here. Adults and children. So let's just say number of adults, and that's going to be obviously an integer, can't have a float. So we initialize that with I'm using camel case here, where the subsequent letters as words in the variable name are uppercase, like the humps of a camel. Let's also say number of children. Okay, so those are definitely things we need. What about the cheese? And you've got like grams of cheese. It seems to be an integer. So it says a partial pack of cheese cannot be ordered, so that makes sense. Okay, so we've got order cheese. Rolls. I guess we've got orders by pack, number of rolls. Let's just check here. So it's 1.5 rolls, so this should be a float, a real number. Number of rolls, we can have order, I guess the order of rolls. If we don't need some of these, we can always go back and amend them, but I think we will. A partial roll or roll pack cannot be ordered. So for the order, it's going to be an integer. And crisps. Got bag of crisps. Let's see, bags of crisps equals 0.75 of a bag, so okay, that's a float. And then how many for the order? Hold on. It says crisps are ordered by whole bags, partial bags cannot be ordered, so that would be an integer. Gosh, that was quite difficult. But it's really important to consider what those global variables would be before we carry on. It was super important to do that. So now we've got the main program. So I guess let's have a look through. We've got an input. So get children, get adults, get children. So this will be number of adults, number of children. They're going to be integers. Input. And then how many adults? Just copy and pasting to avoid errors. How many children? So that deals with this bit. So now we've got a process to go through. Calculate partial bags of crisps required. So a bag of crisps is going to be how many adults and how many children we have, and the crisp per adult, and which we've got up here, and the crisp per child. So what we can say, let's use some brackets here to make this cleaner. Number of adults, and just double clicking with my mouse just to get the variable and to avoid potentially making errors with typing and saving time, times crisps per adult. That makes sense, doesn't it? Plus number of children, crisps per child. I think I'm quite happy with that. And I'm going to put comments in here to calculate the bags of crisps required. So that's the second bit done. Display partial bags of crisps required. Okay, so we've worked it out, and then we essentially just need to print it out. So print, it's a parallelogram. So let's just create a sentence first. Require, and then we're going to need our let's just concatenate these. Bag of crisps, and we're going to convert this to a string so that we're able to concatenate. Concatenate means to join, link in Italian, I believe. So require string of the bag of crisps we just worked out, plus just a bit of English to say bags of crisps. I think that should be okay. Determine whole bags of crisps to order. So it's going to be very similar to this, isn't it? It's going to be very similar. We've got import math. Interesting. Okay, so determine whole bags of crisps to order. So we've got bags of crisps. So there is a way we can do this. In your PLS subset document, there's a feature called ceiling, where we can say, let's say order crisps, this is our integer, isn't it, equals our bags of crisps. But we want to do something clever with it. We're using the math module. I think this is why it's in there. Math.ceiling, which, just think literally goes up to the top. The number goes up to the top, kind of like almost like rounding up. Our bags of crisps. So this is a method within the math module that we can call upon to essentially make sure that we're rounding up. And then we can print it out. So I'm just going to borrow this print statement. I'm going to say order, and then just make a string of order of crisps, bags of crisps. So that way I'm just saving a bit of time and using the pattern I've already got there. It's quite a difficult question for question 4. Display whole bags. Okay, so I think we're okay so far. Now we've got to calculate the grams of cheese required. So let's have a look. I'm going to just calculate cheese. Let's just say the amount of cheese is better, isn't it? Because we do have to add white space to this and comments to get extra marks. I'm going to add a bit of space down here. Okay, so what do we need to do? Grams of cheese is very similar to what we just did, isn't it? It's the number of adults times cheese. We've got that up here. It'll be very similar to this, won't it? So I'm going to copy all of this. equals, but it's going to be cheese per adult instead, and it will be cheese per child. Okay, so it's a little less to write. We've done the hard bit already. Okay, grams of cheese, I'm happy with that, that's fine. The amount of adults times the cheese per adult plus the amount of children plus the cheese per children. Okay, that's fine. And then we're going to also essentially borrow this bit. Print, so what do we require? We require, instead of crisps, obviously we're going to put grams of cheese in here. Grams of cheese. I think I'm happy with that. Obviously we're making sure that we're converting into a string to concatenate, to join up our string. Now we've got a rhombus, which is a decision, which either means we have some sort of loop or usually some sort of conditional statement. I think it would be a conditional statement here. We don't really need to iterate, do we? So is grams of cheese less than or equal to the minimum? Fine. So if I'm just going to copy this. If grams of cheese is less than or equal to min cheese, which is already in there, isn't it? Then we want to print out display order 1 pack of cheese. Okay, so in here order 1 pack of cheese. Else, and that's the no part, if it's a no, determine the whole number of packs of cheese to order. So we can use a similar kind of thing like we did here. So let's say order cheese equals mass ceiling, to make sure we're going up to the biggest number, because we can't have partial amounts of the order. This will be, okay, determine whole number of packs of cheese to order. Cheese is ordered by pack. So I think what we need to do is have our grams of cheese divided by min cheese, the minimum cheese, 500, and then go to the sort of the ceiling amount of that. It's a pretty tricky question for question 4, I'm afraid. Sorry about this. But I'm quite happy with that so far. And then we need to say order cheese packs of cheese. Right, gosh, we're getting through it slowly, but that's this bit all done, essentially. Partial, gosh, so much work to do in this exam question. Calculate partial number of rolls required. So it's very similar. The techniques are basically the same as what we were just doing. Let's just make a comment. Count the amount of rolls and then we're going to say number of roles. It's literally going to be the same thing. But we're going to just make sure number of roles equals, and then roles per adult. Roles per child. So that's the same. Okay, same as usual. And then we're going to have this require, because it's in there as well, isn't it? Require how many roles. So I guess they're thinking, oh, we can cycle some of the content here, but it's still a long exam question. I'm not happy with this one so far. A lot to do and very fiddly. Okay, but let's keep on going. Print require number of roles. That's fine. And then we're going to do the same sort of trick with the math, with the ceiling. And we're going to say number of roles is math ceiling our number of roles. And then we've got this rhombus. Is number of roles less than or equal to the minimum? So if number of roles is less than or equal to min roles, which is 24, then we can say print, because there's a parallelogram in that flowchart, order one pack of roles. I'm literally going to copy it there, if it'll let me. No. Else determine the whole number of packs. So it's the same sort of thing with the ceiling, with order roles. Order roles, yeah, because we want the amount of roles to order. Else order roles equals math dot ceiling. Now we've got to be careful here because we've got to do the same sort of thing as before, like minimum amount of roles. So order of roles divided by the minimum amount of roles, 24. And then print, I think we're nearly at the end, order, and I'm just going to copy this. Order roles pack of roles. Ooh, yuck. And then finally stop. Yeah, about time. So I don't know, we can put how many adults in. Let's say 2 adults. How many children? 2. So we require 4 roles. Order 1 pack of roles. Yeah. Okay. Good. I'm going to move on from that. That took a long time. I could probably add a few more comments to it, but I think I've done it right. But yeah, and there's a lot of repetition in there, but it's just time consuming. Yeah, there's a lot in there for a 15 marker. Anyway, let's move on to question 5. Hopefully this is a bit more forgiving. A program is being developed to work with pasta shapes. The pasta shape names are stored in a one-dimensional array. Fine, okay. There's our one-dimensional array. We've got random, okay, so we might have to get a random assigned number. And we've got constants in uppercase, global variables, good, so we don't have to figure out the global variables. The user is shown a number of options. The user chooses an option. The program performs the task. The program loops until the user chooses to exit. So this is our sort of procedure, which allows you to make a choice to either get a shape, add a shape, show the shapes, or exit the program. So what we are required to do here is to complete this subprogram, allow the user to enter a menu option number, no validation required. So we've got essentially just a very simple like print lines of print, but we don't actually have anything underneath to ask the user for their option. So let's do that first. So write your code. It has to be indented. Oh, we've got more down here. Okay, fine. So write your code here, allow the user to enter a menu option. So I'm going to say menu item and use camel case. It could be, you call it option, you can call it what you like. Let's see. I mean, do they want you to create a global variable, a local variable here? Probably not, but I'm going to put it in just in case. They might want you to initialize the variable and then update it here. They really do like doing that in exam questions. So menu item equals input, and we can just simply say enter a choice. Always put a colon and a space. Okay, that's fine. And then we can actually return this, so it's a function rather than a procedure. We can return menu item. Yeah. I mean, if you didn't have this line, it would work, but I'm going to put it in there just in case. Just in case that's what they need in the returns a choice. So that's fine. I think we're done with this bit. Complete the get shape subprogram. Use a random number as an index into your pasta shapes array. Okay, fine. So get shape is here. We have to indent. Write your code here. So let's just show good practice and have our local variables defined. So use a number as an index. So let's have a quick look at this. Let's read this. Use a random number as an index into pasta shapes. So let's just do that. So I'm going to put ran number, random num, yeah, random number equals, I'm going to say so far it's 0, so because they really like in these questions for you to initialize these variables. And then we're going to say we don't know what the shape is either, so I'm going to put an empty string in here because they're all strings. And then we're going to update these values when we're going to create a number. So I'm going to say, it's a bit overkill to do this, but this is probably what they want. Random number equals random dot rand int. This is in your PLS subset document, and what we want to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 items in pasta shapes. And let's just think get shape. Let's have a look. So pasta table. I mean, it's got to be this, isn't it? Obviously, this is just the name of a parameter, so it doesn't have to be the same name as what we call the argument. So p table, it's 10, but we want to get the length of that p table and take 1 away from it, because we go from 0 to the length of our parameter p table, and we've got to take 1 away from that to get, because if we're going from 0 and we had 11 in, if we went 0 to 10, we've got 11 things, and there aren't 11 things in here, which would have an out of range error, which is why we have to put that -1 in there, otherwise we get out of range. It's very typical for range questions, when we get the length of an array or a data structure. So we're getting a random number between 0 and 0 and 9, essentially, because the last index value is 9. That could randomly choose an item in the current one that we have. If we added more to it, obviously we'd have a greater length. That, I think, is okay. And then we can say the shape equals whatever our p table at our random number index. So we've got a random number between 0 and 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, Fusilli's 9. We've got a random number for the index, which makes sense, it's in range, and then we can return the shape. Okay, that I think is fine. We're happy with that. This is a difficult test so far. Complete the add shape program. Let's have a look at it. Add a shape. Fine. Okay, so add shape. Let's just say shape name. We don't know yet. We don't know what the shape name is. We're going to add to it, and then we can say shape name equals input into a shape name. Well, let's say a new shape name. Okay, and I'm happy with that so far. And then to add this shape name to our list, what we want to be doing is appending it. So we've got our pasta shapes. I'm almost certain p table is that, so we're going to use p table dot append, because this is just the name of a parameter. That's what p stands for, parameter. P table append, and then we're going to append the shape name to it, so that will add to the end of our array. It would be like, there'll be one here, and that's a procedure. It just does something. It doesn't return a value. So I think we're happy with that. I'm quite happy with that. That is all of our, we've got our libraries, constants, global variables, data structures, and subroutines, or subprograms. And then finally, the main program area. What you do not want to be doing is adding any of that stuff into this main program area. So finally, in the main program area, we want to have some sort of logic where we call each subprogram based on the menu option. Okay, so the best option here is just to carry on doing something until a condition is met, which is a while loop, a condition controlled loop. That makes the most sense to me. So I'm just going to make some space. And it says write your code here. Fine. So I'm going to put this here. Write the code underneath. Not mess around with that. Choice equals get choice. That's fine, because what we're doing is calling this subprogram from, and we're adding it to that variable. Fine. Okay, so get choice is going to print out these options. They're going to enter a choice, and as long as they put 1, 2, 3, or 4 in, we can run it. Now, it makes sense to exit the program and exit a loop. If we create a while loop, to exit on that condition, essentially. And we've got, oh, here we go. We've got a constant called exit. So we're going to borrow that. So we're going to say while choice does not equal exit. As long as it doesn't equal 4, we can carry on asking, like, what do you want? And then I think we better look at all of these. These are going to be helpful for us. So I'm just going to pop them down here for now. If choice does equal get, then what do we want to do? We want to get a shape, don't we? So we can just say shape equals get shape. Now, what we're passing through here as our argument needs to be this as a global variable. It doesn't matter that the parameter p table, p for parameter, is named differently, because this is going to get passed, this argument gets passed through that parameter. So shape is get shape, we're passing through our data structure, and then we can say print, because if you return something it doesn't actually go to the screen, your shape is, and then comma shape, because that's going to contain the return value. So I'm kind of happy with that. And then else if, elif, choice equals add. That's the second one. We'll get rid of these as we go. Then we can say, I don't know, add shape. Here it is. Add shape. And then just call that function. So pasta shapes. So that's what we do. And then when we call that function, or let's say what, enter a shape name, it will append it. And then after that, we can, no, that's fine. That's all we need to do. elif, else if choice equals show. Show shapes. We're going to call that subroutine. Notice how it's so much cleaner to have the subroutines somewhere else and just call them on here. If we had to do all of this logic inside these conditional statements, it'd be such a mess. And then let's pass through pasta shapes as our argument. And that's it. We're already dealing with exit. We just want an else, so if we didn't recognize what they say. And then we can just say print that choice is invalid. And then finally, before the end, we still want to ask them what their choice is. So we want to go back to this menu. So each time the while loop goes round, we can ask them what do they want to do next. Now, if they type in 4, it will be while choice does not equal 4. Well, if it equals 4, the while loop will stop running. That'll be it. You could say not in menu, something like that. Gosh, this is a tricky paper. so far and very time consuming. Let's have a look at the last question. I hope this question is not too bad because we've taken a lot of time to answer this question so far. I mean, I know I've been explaining it, but we're probably at least at the hour mark here. I mean, you get 2 hours in the exam, obviously, but you know, if I'm explaining it and taking an hour, that's quite a long time. Right, here we go. So, okay, let's look at question 6 then. A program is required to process data about cows. The data is stored in a comma separated value text file named cows. That's going to be in our folder. There it is. Let's have a quick look at it. So Annabelle, Highland, and then there's some sort of number there, tag number. Good, okay, so name, breed, tag number. The columns, right, so maybe we have to do a two-dimensional array here, we'll see. Write a program to meet these requirements. Create a key for each cow in the data. A valid key is a single string consisting of, in this order, the first 2 letters of the breed name, tag number integer divided by 100, the first 2 letters of a cow's name. Fine. I think this is doable. We can use slicing to do this. First 2, and then create a record for each cow. And the key, tag number, name and breed, store the record on each cow in the cow table, call the supplied subprogram show table to display the contents of the cow table. The program must work with any number of lines. Okay, so it's just got to work for basically anything that we have in there. Fine. Right, so let's have a look at this then. We've only got just the global variable initialized with the initial structure, and as soon as they said columns to me, it's thinking about a 2-dimensional data structure, because essentially that's a table. So what we need, if there's a record, we've got to construct a key. So I'm going to make these global variables first. We need a key. We can also say, let's have a record that we're going to append, and also all the different fields. I think we're going to need all of those as a Python list. Key's a string that we're going to construct. And then we've got this basic subprogram, show table for cow end p table, print cow. Right, so that can stay where it is. I don't think we need to do anything out with that. That's a procedure. Right, so we want to open this file. And we can do that by saying, just create a variable, initialize it, and then just say open. And what's it called? It's called cows.txt. So I'm just going to copy that with the extension cows.txt, and then I'm going to open it in read mode. So we're going to read however long the file might be. We're going to read the contents of the file, and then we want to use a for each loop. So let's put a comment in, because it says use comments. Process each. Process all lines in the file. Let's just keep it simple. Process all the lines in the file, and we can do that with a for each loop. So for line in file, then what we want to do is, we've got this global variable that we initialize called fields, and we can use that to store our split up record. And this is a really clever trick we can do. First of all, what we're going to do is strip the line of any like new line characters or anything invisible or any junk. So we're going to say line equals line dot strip, and this will strip from the left and right, like a new line character, for example, because we don't want to have that. And then we can say our field is line dot split, and we can split up at any point we like, but we want to split up at commas for comma sequence. So I'm going to put in a comment here: split at each comma. Remove new line characters or spaces, right? Because we do want to comment this code. Now we want to build up our key. So what does the key? Well, let's put a comment as well. Why not? And it tells us what the key should be. If we create a key, a valid key is a single string, first two letters of the breed name. So we can say key equals, and we've got our list now. If we printed out off fields, it would be a list of all the different things you see in cows. It would be square brackets, Annabelle, within quotation marks, and so there'd be 3 list items in there. So now that it's a list, we can use indexing. So we can say fields. We want what's the breed name? So the breed name is the second thing, Highland. So Annabelle would be index 0, Highland would be index 1 of our data structure there. So we want index 1, and then we want, I guess it's just the well, let's just do it in pieces. The first character plus the second character. I think that's the easiest way of doing. I mean, I think we could probably get away with that, but I'm just going to play it safe and just do them as separate, concatenate them as separate things. So that's literally the first letter, and that's the second letter, because strings are in themselves data structures. Now I'm not done yet, because I also want to add to my key. I want to concatenate more stuff. So the tag number, so this is going to be whatever I've already got in key plus my fields. What's the tag number there? So 0, 1, 2. So I've got to be really careful here how I do this. I've got to make sure whatever I do is got to end up being a string. So first of all, I've got to make sure that I convert whatever I do here into a string. And then I want to say I need to convert my fields index 2 to an integer before I do a calculation. So fields index 2 is the number, so I need to have that as an int, and I need to do integer divided, tag number is integer divided by 100. So I'm going to do floor division 100 here, because you can't have a partial tag number. I think that's right. So let me just check here. Yeah. And I'll just remove this. It's just so I can see what's going on. So I'm doing the arithmetic inside these brackets, and then I'm converting it to a string so I can concatenate it afterwards. Bit fiddly. Key equals first 2 letters of the cow's name. So that was the index 0, Annabelle. So I want to add whatever I've already got for key plus fields but index 0, which is a cow's name, and it's going to be the first two. So I'm going to do it the same as last time. Just going to play it safe and do the first letter and the second letter separately. I think we're okay here. And by the way, you can always print out key to see if it actually works. Use print statements and then delete them afterwards if you know that you're getting what you need. Like you can print out fields to see it as a list. Right, let's carry on. I think we've built up our key. I'm kind of happy with that. And now we need to construct our record that we're going to append. So I'm going to construct record. So I'm going to say our record, which we've initialized as an empty list, equals it's going to be essentially our key, isn't it? What have they asked for? Key tag number. So that's field 2 is the tag number. I can literally construct a Python list like this. Field name, so that was the first one, field 0, and the breed was the index 1, the second item on the record. There we go. So that's our record that we've made. And now I need to save the new record. And I can save that by appending it to cow table, which already exists up here. So I'm going to say cow table dot append. That's the method to add. I'm going to add my record. So it's going to be a two-dimensional data structure with records in it, essentially like columns and rows. I think that's it. The only other thing, whenever we deal with files, we have to close them. We have to use this dot close. So we just called it file, didn't we? So we can just say file dot close. We have to do that at the end. We also do we want to call the supplied subprogram show table. So we want to call the program as well. So we've done all of our work, and then we can just say show table, and the cow table is the argument that we put in here. Now I know show table says p table, that's a parameter. It's just the name of a variable. That's it. So cow table is our argument. So that's why they're named like different things. And I think that's gonna work. Let's try. And we're showing it. And we've got a tag. We've got a key, a tag number, the name and the breed. Good, I think we did it. Wow, okay. That was a pretty tough exam, that one. Took a long time. So anyway, hopefully you've watched this and you've learned a lot of techniques, and it will give you some confidence when you have your own GCSE